everyone. Today in this session we are going to talk about the law of conservation of momentum. I guess every one of you had heard about the word momentum before, because in Newton's second law of motion we did talk about momentum. So I will just recapitulate the momentum for the time being. So actually momentum is denoted by letter P. It indicates that whenever there is an object which is having a mass and having a certain sort of velocity, we call this particular kind of object, they are in possession of a certain kind of momentum. So momentum, normally we are concerned with mass into velocity. Mass and velocity. For example, okay, I have a ball and this ball is having a certain kind of mass, and this ball is also like rolling down, is having some sort of velocity. So these kind of like examples are an example of an object having momentum in that. For example, if I am throwing a chalk, this chalk is having a mass and it is moving with some sort of velocity, so it is having some sort of momentum. So now today in our this topic here, what we are going to talk about, we are going to talk about law of conservation of momentum. So generally, this conservation here, this particular word conservation, in my own word, okay, I normally used to say conservation means constant and not changing. Constant and not changing. Now, speaking in terms of law of conservation of momentum, I will just explain you theoretically over here. Okay, there's a car. Let's say this is number 1, and there is another small vehicle here. Let's say this is a bike which is at rest, and this is number 2. Now this car is moving in this direction here, and I'm going to use a word called collision here. Collision means backing with each other. Understand? So now this particular car is going to collide with this particular object over here, which is the bike here. And what will happen now? We know that whenever this particular object number 1, that is car, is having a huge mass here and is moving with some sort of velocity here. Now this particular bike is at 0 velocity, that means it is at rest. So we know that the impact is going to happen whenever there is a collision here. For example, this is a bike and this is a car is coming over there, and this car is coming with some velocity and it is going to hit this one. Now after hitting, we will talk about the another situation here, that this bike is going to be thrown away, and let's say thrown away, and this particular car is having some sort of velocity, and this car is having now a velocity. This velocity is lesser than this velocity. Why? Because this car is going to collide with this particular bike, and this bike will be thrown away with a more velocity, whereas the velocity of this car is going to get reduced. Understand? So what I'm trying to say, in according to law of conservation of momentum, what they are saying is that if the momentum of this object plus the momentum of this object, let's say if this is like 100 kg per second, then the momentum of now this object here, which is being thrown away, the bike, the momentum of this and this should be 100 kg per second. This will not change. Verbally, what I normally say is that the total momentum of two objects, object number 1 and object number 2, before collision, and the total momentum of the object after the collision here, 1 and 2, is always same and is not changing. That is the law of conservation of mass. I can give you another example here. Okay, let's imagine 2 balls here. Fine. This is ball number 1 and this is ball number 2. So let's write this as number 1 and this as number 2. And this belongs to one system. This is one system, right? Okay, mass is equal to 5 kg. This ball, we are assuming it for the time being, and the velocity, this is coming with 4 meter per second, moving 4 meter per second. Now if you look at this one here, this is having a mass of, let's say, 2 kg, and this velocity is 1 meter per second. That means it is slowly rolling down, whereas this particular ball is moving with the velocity of 4 meter per second. It's moving with more greater velocity. Now what will happen? At some point these two are going to collide with each other. So let us try to calculate here now. See, now the total momentum of this. This is object number 1. I'm going to write P1. Okay? And P generally goes for the symbol of momentum. P1 plus P2. Understand? This is the P2 here. Now, this P1, M1 plus U1. Over here, I'm going to take U. Why? Because I'm going to take U. Because U is the initial velocity. We are also going to take this example on that side. Okay? M1 U1 plus M2 U2. Okay? So now, what is the M1? It's 5 into. What is the U1? Is 4 meter per second. 5. Okay? Plus, what is M2? Is 2. And what is U2? Is 1 meter per second. Is equal to 1 meter per second. Now, how much is that? 5 4s are 20, right? 5 4s are 20 plus 2 1s are 2. 20 plus 2 is 22 kg meter per second. This is the total momentum in this case over here. Okay? Now what will happen? Okay, these two objects, this is before collision here. Before collision. Before collision here. Now let's say, now these two balls, they are moving and they met with each other, they had a collision, and now we will see what will happen, okay? This ball here. This is object number 2 and this is object number 1. Okay? Kg again, and velocity. This is 2 kg again. Okay. Now let us imagine here. There is a bigger object and there is a smaller object here. Now these two are coming. Okay? This particular small object, they are coming with a very small kind of velocity, whereas this bigger object is coming with a more amount of velocity. Now what will happen? When they back with each other, the moment they are collide, what will happen? This smaller object will be taken away, will be thrown away to a greater distance with a more kind of velocity here. Now in this case here, the velocity, in this case velocity is 1 meter per second. Now in this case, do you think the velocity will be 1 meter per second? No, because this object is going to exert some amount of force on this particular object. So let's say the velocity in this case now, the velocity has become 6 meter per second. Greater distance. Okay? So let's say velocity is 6 meter per second. Now the moment this particular bigger object, when it collides, the velocity of this particular object is going to get reduced somehow. So let's say the velocity in this case is 2 meter per second, reduced from 4 to 2. Understand? Now we are going to find, that is P1 plus P2. What is P1? M1 plus V1. Now this time we are going to take V. This is initial velocity, this is final velocity. Plus M2 V2. Okay? What is M1? That is 5 into. What is V1? 2 plus. What is M2? 2. What is V2? 6. Calculate. 5 2 is up. 10 plus 6 2 is up. 12 is again 22 kg per second. So now do you see that this momentum and this momentum both are same in that case? So law of conservation of momentum, it says that the total momentum of two objects, that is the momentum of this object and that object summing up and before collision, is equal to the total momentum of two objects after collision. After collision, there will be another kind of momentum in this and that. These two momentums are somewhat same here, 22 kg per second and 22 kg per second. This is in the case of after collision here. After collision. Is that clear? So this is the law of conservation of momentum. So related with this particular law of conservation of momentum, I took one question over here. This question we will try to solve this out. Okay. Okay. Now first, before solving this equation, this question over here, we will try to understand what this question is saying, okay? Let's say there's a gun and yeah, this is a pistol here, okay? They have written here pistol here, okay? Yeah, okay. So now they are saying that a bullet of mass 20 kg, that means in that particular pistol, there is a bullet. Let's say this is a bullet. Okay? A bullet of mass 20 kg, 20 gram is horizontally fired. Okay? They say that a bullet of mass 20 gram is fired horizontally. Okay? With a velocity of 150 meters per second. Here, there are the two things here. This is a gun again. Now they have fired the bullet and this is now moving with 150 meters per second. Before, when this bullet is in a gun, it is not moving. It is 0 meters per second. Understand? Now, from a pistol of mass 2 kg, now this pistol is having a mass of 2 kg. Understand? What is the required velocity of the pistol? What is the required velocity? Required velocity is normally we used to call as the backward velocity. For example, if I fire a pistol, this pistol, the moment I am going to press the button, the bullet is going to move in that direction and simultaneously I will have backward velocity. For example, when I fire, this pistol is going to apply a backward velocity. In that way, this velocity is what we call as required velocity. Is that clear? Because if this is a pistol, this is going to apply another velocity in backward direction here. For example, that is why people who are using gun, when the moment they are using, they used to bend down a little. They used to keep the gun over here. Why? Because this gun is going to apply some sort of backward velocity to our body. So we have to find it out now here. So now according to law of conservation of momentum, they say that m1 u1 plus m2 u2 is that momentum of two objects before collision and after collision is same. Okay, so now I'm going to find this out. Okay, now here mass 1, we are going to take pistol here. This pistol is having a mass of 20 kg. Okay, I will write on this side here so you will understand in a better way. First I will write the given part. Forgot about the given part. Let's say this is a gun. M1 is how much? 2 kg. And this we never know that this gun is moving. U is 0. Is that stationary position here? Okay. Now let's say okay. Now this is M1. This is U1. V1. This is the required velocity which we have to find. required velocity. Please don't get confused. Okay, let me stop writing this. Okay, we will first try to go for it. Okay, now M2, that is the bullet. M2 is 20 gram. Sorry, 20 gram. The moment you are going to convert gram into kilogram, it's like 20 divided by 1000. So that means you will get 0.02 kg. Alright? So now 0.02 kg is the M2. Now again U2. That means when the bullet is in the pistol, it's not moving at all. Understand? So this U2 is again 0 meter per second. So now I'm going to find it out. Okay? M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Okay? So what is M1? M1 is 2 kg plus U1 is 0 plus M2 is 0.02 kg into how much is U2 is again 0. That is equal to, what is M1? M1 is 2 kg again into this V1 is the velocity that they are going to push backwards here. This is V, I'm going to write. M2 is how much? 0.02 here. M2 0.02 into what is the velocity with which this bullet is moving. Now this situation is the one where when the bullet is being fired. Now when the bullet is moving at a speed of velocity of how much is that? 150 meter per second. That means we have to write 150 here now. Okay? So 2 zeros are 0. This is the whole things are going to become 0. Why? Because this is everything is multiplied by 0 is 0. Now in this case this is 2V plus this 150 and 0.02, when you multiply you will get 3. Understand? Now this plus 3 you're going to send this to that side. What it will become? Minus 3 is equal to 2V. This 2 you send it down there, minus 3 divided by 2 is equal to V. You cancel it off, minus 1.5 meter per second is the V. Now this is the required velocity, 1.5. But why this minus? Because that particular velocity is in the opposite direction there. Is that clear? So this is how we find the required velocity of by using the law of conservation of momentum. And I hope every one of you have understood very well. So I shall continue. I'm done with this chapter of force and laws of motion. So I shall see you in the next class. Thank you very much, all of you.